Hi folks, let's today demystify and deconstruct the concept of functions in any programming language and understand its implementation specifically in C language. Let's start off with a simple example which is not at all related to programming. Imagine you are a car manufacturer and you want to hire employees and train them so that they will be effective in working in your organization. One way of doing it could be that you prepare a human resource team, then hire suitable employees, and then train them all by yourself. Another, more effective and simple way of doing the same can be taking help of an outsourcing firm or giving it to a BPO, which can handle the hiring and training of employees and then return you back an excellent team which is both effective and efficient for you. This simplifies and decomplexifies your work to a great extent. That is pretty much why we use functions in any programming language too. Applying the same logic in programming. Firstly, we have a main program which includes codes that perform different action, like the one for hiring or training as we saw in the example. And here on the other hand, we have another code where every function is modularized into its separate code. Now it's also important for us to understand the different type of functions, especially in C. The first one is predefined functions. These functions, as the name suggests, are predefined and are declared in files known as header files, which we include in our code. So stdio.h is our header file. Some of the examples of predefined function are printf, scanf, the cosine function or the sine function, etc. The second type of functions is user-defined functions, which is going to be the topic we are going to discuss today. Any user-defined functions has three parts to it, which can be better understood by PCD. P is for prototype, C is for call, and D is for declaration. If the function is declared before the main, then the prototype can be ignored. Enough of theory now. Hop onto your favorite IDE and let's start coding. In this code, let us try to understand how the control passes on from a function to the main. If you can see, main is also a function because it follows the function parameters. As I said you earlier, every function has three important parts: the prototype, and then the function call, and finally the declaration. So let's write a simple function starting with its prototype. So you can see the syntax I've written here. First is the returning data type. As we know, C has 4 data types. It can be any one of them. Then we have the function name and with arguments. So arguments, there's not a necessary for arguments. It can be a void argument too. So let us write it in that way. So I write void and then I write the function name, a dummy function. And then in the arguments, I will not pass anything. So either I can write void or I can just leave it as it is. Every function prototype ends with a semicolon, which is very important. Then we can now declare the function because we have written a prototype of it, and hence it becomes easy for us. In the function declaration, we again write the returning data type and again we write the function name. Make sure that the function name is perfect even in the case, because if the case is different, then C will give an error message that such a function does not exist. Now we have a dummy function and all the code goes inside. So here I'll be writing a normal printf statement. Now I'll go ahead and write in my main and I will therefore call it. So before that, I would like to write a printf statement inside the main. And now I will initiate the function call just by writing the name of the function and then with the opening closing parenthesis and finally a semicolon. It's similar to the function prototype, but here we do not signify the void or the returning data type. Then I again write another printf to show that how the control comes back to the main. I will just give a new line character so that it prints in a new line, and I here too. Now let's compile and see how this works. Now as you can see, the first one was inside main, and then it went to the function and then printed that this line is printed in the function, and then this came back to the main and printed the statement. So I hope you understood the control of how the statements work. The previous example was kind of irrelevant and was made just to show the control. Now we'll try to make a similar function which can be used over and over again in realistic circumstances. This is going to be the last example and I'm gonna go through this very fast. So here, with the help of functions, we can find permutations and combinations pretty easily because all of them require the factorial function, and unfortunately there's no factorial function which is predefined into C language. So in this code I have written the factorial function, prototype, and the declaration right below, and let's see how I can integrate this into the main and repeat it for n number of times. Okay, I first of all create two integers, n equal to 6 and r equal to 3. And now in order to find the permutations, I can just write I can create another integer for permutation, and inside this what I can basically do, as we all know, the formula of permutation is n factorial divided by n minus r factorial. So I can write permutation is equal to fact of, as you know, as you can see that the function name is fact of and it takes in an integer. So I write n and this divided by fact of, here I give n minus r and I close the semicolon. Now I can basically print f permutation and in order to take this we will need %d, and let's see if everything works out well. As you can see, 120, which is 6p3, we have found out using a function. Now you can basically include any number of things over here. You can just find the permutation again and again using the fact of function, and the best thing about it is that you can use combinations with that too. So it would be fact of any number you wish to write. So 78, it could be as big as 78. Now I'll just reduce it to 10 divided by factorial of 10 minus 4, which is basically 6. Now I'll repeat this line again. You can see 5040 is the permutation of so and so. Thank you and have a wonderful day.